complex thing is how we can represent the data. For example, you take your age. How do we represent the age? Somebody's age? It's numeric. Correct? So there is a data type associated with it. Name. It is alphanumeric. Okay? Or you can say character. Right? So like this for every field, every entity, we have so many data types that get associated, and we need to understand how we can model this or how we can represent this. That's exactly what we are trying to understand here. There are two types of models. Here, the left side what is given, the object-based model, you will not be going into in your earlier studies of education, except for the last one, ER model, which when you are going into your database course you will understand. I will also explain what is this ER model little later. Okay, but the right side, what you see, this record-based model is what we frequently use. Okay, we have a network model, hierarchical model, but the most popular model is the last one called relational model. Okay, so we are going to understand only relational model in this course, in this lecture, because at least 80 to 90% of the IT applications run using this relational model, and it becomes essential for every computer science student to know what is a relational model. Okay, so before we go into this, we should know what is a database. Anyone? If you already know what is a database, can you tell what is a database? Collection of? Sorry?
Collection of raw facts and figures.
Collection of raw facts and figures is a database. Then what's a file? Collection of data. See, first of all, there is data is plural. Okay, data. There is no word like data. Okay, data is plural. Datum is singular. Okay, fine. I will tell you. Okay, what you are saying is right. Collection of data. But before that, we should know that there is something called a file. Before knowing a database, we should know what is a file. I think you come across so many files. At least, in your first year people, even the second years you would have used, and you may be developing, and you may be interested in creating a spreadsheet. In which case, you may use an Excel, or I use something. What is this? PowerPoint. So all these are stored in file. Okay. In database, in database terminology or in our computer science terminology, we have something called a flat file. We have something called a flat file. A flat file is nothing but all the files which you talk about, which you create. Okay, your Word document or an Excel document, an Excel file or a PowerPoint file, everything is called a flat file. Okay, the problem with flat file is, suppose I created a flat file, put it in the desktop. You come after some time. Okay, you don't like me. What do that? After some time, if I come, I will get perplexed. Right? So, the problem with a flat file is there is no security. Anyone can create and anyone can, I can create and put it there. Anyone can come and delete or modify or do anything they want. Even they can send it to their mail ID. Okay? That is stealing. That is something different. Okay? So, this is the problem with flat file. So, how can I put some data at the same time protect it? For that I need a database. Now the question is, how can I protect the data if I am creating using if I create using a database, right? So, we should know how we create a database. To understand a database, we should know a term called table. Anyone knows what is a table? Collection of? Very good. So collection of rows and columns. Okay. What is a row? What is a column? So the moment I say rows and columns, it becomes two-dimensional. Correct? It becomes two-dimensional. If I have just one number, it is one dimension. If I am going to put it in a table, it's a matrix, right? It becomes a matrix. That means it is two-dimensional. Now, every row, okay, first of all, every column, we'll talk about every column. For example, if I am talking about student, okay, if I am talking about a student, I know that there is a student number. Everyone has Anna University has assigned a registration number. Then name. Then marks code in subject 1, subject 2, subject 3. Right? Now, each of this is what I call as a field. Okay? And that becomes a column. Now, if I want to know if I want to know a particular student's details, I pick one row. Okay? I pick one row. For example, 1, 2, 3, 4. Okay? Ram. Then B. Computer Science. Second year. College. PERI. Okay? Next. 68. 82. 96. Now, this particular one row is what I call as record. The collection of records constitute one table. Okay? For example, in this case I say student mark table, student performance table or student marks table. Now, there may be another table. Okay? I may create another table where student result table. For example, in Anna University when it comes, you don't get the marks and all. What you get? Grades. Right? And there is a rule for the grade allocation. Right? If it is between 50 and 60, it is E, D, C, B, A, yes. Correct? If it is above 90, we may say yes. Now, from the marks table, I create a grade table. Now, is there any link between these two? Yes or no? Yes. What is the link? For every student, okay, depending on his mark, the grades are allocated. So, if I have 100 students in PERI Institute of Technology, then even in the grade table I am going to have 100 rows. Which means there is a relation between table A, which is marks table, and table B, which is grades table. Because we connect this using a relation, we call this as relational database. Okay? So the relation is otherwise called association. Okay? The relation is otherwise called association. So the relation, what is the relation in this case? For every mark I have some rules. Based on the rules, I assign the grade. And create every record for every record that is present in the table A. If I call table A as marks table and table B as grades table, if there are 100 records, there also I need 100 records. So there is a relation between these two. Now, what is this 1, 2, 3, 4, 5? I told no first. For every student, what is it? Registration number. Why I need a registration number for identifying you? Because in the single class itself, you can have 2 Raghus, 2 Suganyas, right? So, imagine in Anna University how many people will have the same name. Okay. In fact, in my BE class, we had 8 Sivakumars. Okay, of that 3 were Shivakumar Srinivasan. Okay, so they will identify using the date of birth. Okay, so because I want to identify everybody uniquely, you are given a number, a registration number. That registration number for that table becomes primary key.